Welcome back to Aurora Tech Channel. Today, I will review the Creality K1C, an upgraded version of the original K1, which is Creality's first fully enclosed clipper machine that was launched last year. After 1 year of user feedback and suggestions, Creality launched this K1C a few days ago. The appearance of the machine is almost identical to the original K1, which was priced at $499. But this new K1C is $60 more expensive at $559. So, let's see what we can get from this new machine. Like the original K1, the K1C is a clipper-based firmware machine. It features a one-piece die-cast metal frame, a motion system that uses linear rods, and a Z-axis with 3 lead screws synchronized by a timing belt inside the base. It operates on a Core XY kinematic system. The printer is fully enclosed by 4 acrylic panels, a top cover, and a glass door. The maximum printing speed remains unchanged at 600 milliliters per second, while the maximum nozzle temperature is 300 degrees Celsius and the heated bed can reach up to 100 degrees Celsius. The Clipper motherboard is powered by an Ingenic X2000E 1.2 GHz dual-core processor equipped with a SanDisk 8GB onboard eMMC and silent stepper drivers to support sensorless homing. There are also standard features such as a 350-watt power supply, a color touchscreen, a filament sensor, Wi-Fi printing capabilities, and offline USB drive printing, all of which are consistent with those of the K1. For the $60 price difference from the K1, the major upgrades include the all-metal gear extruder, which Creality claims has been tested for over 1,000 hours of clog-free printing. Additionally, the heat break has also been upgraded to a quick-swap tri-metal heat break, and it comes with a hardened steel nozzle, letting it print carbon fiber filaments right out of the box. Unlike the old K1, the K1C also features a built-in camera, eliminating the need to purchase and install one separately for an additional $20 or $30. Some minor upgrades include a carbon air filter on the exhaust fan and a silicone wiping strip at the back of the print bed for nozzle cleaning. Other small improvements include glass door, hinges, cable chain, and the anti-vibration rubber feet are now fixed on the base. I would like to thank Creality for sending us this machine and for sponsoring today's video, and with that, let's get started. The box of the K1C is about the same size as the original K1. Once I open it, the first new thing I can see is the new unboxing instruction card. The whole machine is one piece, and it's surrounded by laser-cut foam and cardboard. You can just lift the machine out of the box by grabbing the plastic bag. Remove all the protective materials and accessories inside. Besides the machine, we have the top cover, the touchscreen, filament holder, an air filter, a 200-gram roll of sample filament, and some tools and cables. There are a few things you need to install. At the front, we need to install the screen and the door handle. At the back, snap on the filament roller and the filter on top of the exhaust fan. Before we can turn on the machine, flip the power supply switch to your local voltage. Once the machine is on, select language, and it also reminds you to remove the 3 screws that fix the print bed at the bottom. There are 3 yellow arrows pointing at those screws, but just remove the silver one in the middle and don't touch the black ones. Here comes the agree to whatever it says screen, then connect to your local Wi-Fi network, select your time zone, and for Creality Cloud, I'll just skip it. Then it will run a self-check wizard, which will take around 11 minutes. It starts by heating up the nozzle and bed and testing the fan. Then it's going to calibrate the input shaper. When the bed rises, I see there is some remaining foam placed underneath the bed, so I will also remove that. It's going to home the machine, then start input shaper calibration. After that, the print head will move to the back of the print bed and use the brush pad to wipe the nozzle. I can see some filament residue still stuck at the left side of the nozzle, but I don't think it'll affect the bed leveling. It will probe the 4 corners of the bed, which is then followed by a 25-point auto bed leveling. Okay, the self-check is now done. Let's go to the filament menu and load in some filaments. We need to load the filament from the back. Let it go through the filament sensor and the Bowden tube, which works as a guide to the direct extruder. Okay, the new blue filament is coming out. As this flat print surface requires you to apply glue, I will just use the glue stick that came with the machine. Let's start with the 16-minute Benchy preloaded in the eMMC. As the machine was just calibrated, I will not check the calibration box. It starts with homing and moving the print head to the back again to wipe the nozzle. Then, it goes back to the center to set the Z offset. Once the second layer is finished, it will print at its top speed. As the print head is now moving fast, let's test the sound level. The sound meter is about 6 inches away, so when the printer is printing at high speed, with the door open and without the top cover, the sound level is around the mid to high 60s. When the door is closed, it drops to around 60. Once we put on the cover, it drops a few decibels to the mid to high 50s, but when printing low temperature filaments like PLA and TPU, you can't fully enclose it as the hot end will get clogged easily if the internal temperature of the machine is too high. The print finishes in 17 minutes. The surface of the Benchy is alright. The layers are not perfect, but are still in line with other new generation fast machines. With the powerful auxiliary fan, the cooling at the front is good, so overall it's a pretty decent 17-minute Benchy. Then, I will do one more test print from the sample G-code. This is actually my favorite print to watch, that being the 600 milliliters per minute high-speed printing test. When the K1 first came out, this test print at 600 milliliters per second was really impressive. As the printer is printing at the top speed, let's check the sound level again. It still stays in the high 60s, so I think the loudest thing is the auxiliary fan, and the rapid movements of the print head don't actually change the sound level at all. The print finishes in 9 minutes, and even though this is a wall-only print, being able to print something in this size for 9 minutes is still pretty amazing. Up next, I will run a few of my usual test prints, starting with the number slider to test the clearance of this machine. On my first try, the Auto Z offset was a bit low, but like all other machines with Auto Z offset, there's no option to manually adjust it. It may be fine for other prints, but for this number slider, we need the first layer of all the tiles to include small gaps in order for them to move smoothly, but I will just let it finish. The top was printed nicely, but as expected, the first layer's tiles are too close to each other. I can still snap them apart and make the slider usable, but when I asked Creality about this, they released a new firmware update that added the Z offset adjust feature. So I will reprint this model and set the Z offset to 0.05 millimeters so there will be more space between the nozzle and the bed. As I just ran the same G-code again, the front looks the exact same. However, the bottom looks completely different. The one printer with the extra 0.05mm between the nozzle and the bed can move freely without any post-processing. Then, I will print the tolerance test and see how well parts fit with each other. This print took less than 2 hours, which is one of the fastest I have ever printed. Let's check the tolerance, starting with the square side. It can clear from 0.225 all the way to 0.1 before getting stuck. For the cylinder, it can clear from 0.225 all the way to almost the tightest of 0.05. While the last 1mm can't slide in smoothly, the result is still pretty good for the cylinder, and it's average for the square, which is mainly caused by the overshot corners. Next, I will print my honeycomb box with tiny patterns to test the extruder. It requires the extruder to extrude a bit of filament and retract immediately, so let's see how this extruder can handle this. The print finishes in 2 hours and 14 minutes. It's slightly faster than the average 2 hour and 30-minute print time on other new generation printers. Besides a tiny bit of stringing, all patterns are printed without issues. Let's compare it to other printers. In terms of stringing, it's better than the Creality CR10SE and the Cheedy X Max 3. Compared to the Prusa MK4, the MK4 has some broken patterns. It's on par with the Bambu Lab X1 Carbon, but when compared to the Bambu Lab A1, the A1 is slightly cleaner. Then, I will print a decorative print, the Robo Alpaka. For the infill in the body, I tried to boost it to 400 milliliters per second, and it seems it can still handle it pretty well. This print finishes in 4 hours and 28 minutes, and the result is very good. Let's take a look at it from all 4 angles. Compared to the K1, the surface quality is much better, and the vibration compensation seems to be working much better. When compared to the AnkerMake M5C, the K1C prints faster with slightly better print quality. When compared to the Bambu Lab A1, the K1C printed faster and the surface quality is very similar. When compared to the P1P, the P1P is slightly faster and the print quality is also similar. As this printer can handle a broad range of materials, I will test it with a real project. We recently got into film cameras and tried to develop the film at home, so we bought a Paterson Tank. As we need to agitate the reel in every process, we end up having to do it repeatedly when the chemical is soaking the film. So, we will use a stepper motor to do the job for us. In order to do that, we need to design a coupler for the stepper motor, make the shaft the agitator, and make a motor mount to connect the motor with the lid. As the lid is printed with TPU, it may be too soft to support the motor, so we will add a plate to support the weight of the motor, and a connector to easily remove the motor if we need to pour chemicals in and out. So, we have to print these parts with regular filaments, PETG or PLA PRO, or even regular PLA. For the lid, we will use TPU. For the stick to work as the agitator, since it will have to soak in chemicals, we will use ASA as it generally provides better chemical resistance. So, let's start with the TPU lid. It looks like the TPU is getting a bit moist. Our garage is pretty dry most of the year, but it's been pretty rainy, resulting in some extra humidity getting into the filament. But as it's a functional part, after some simple cleanup, I think it should be fine. Then, we will have the printer fully enclosed to print the ASA stick. When the printer is fully enclosed, we can expect the temperature to reach around 40 degrees Celsius or higher, but as the fan at the back is exhausting air out, the temperature stays at around 38 degrees Celsius. I tried to turn it off on the screen, and it stopped for a while, but for some reason, it turned on by itself again once the temperature went over 40 degrees Celsius, or a certain degree sensed by the printer, but around 40 degrees Celsius should still be alright from the ASA stick. This 125mm tall stick took 44 minutes to finish. Finally, we will print the rest of the parts using regular filament. You will use some new VOXEL PETG Plus to print these parts as the stepper motor will get warm depending on the current and how long it runs. So PETG should be better than PLA in this case. The print took 2 hours and 48 minutes to finish. Now let's put everything together and see if they fit. The clearance of the coupler and the mount is okay, and the shaft is doing a half turn to work as an agitator. So let's put it in the tank. It seems to be working. Besides doing a half turn back and forth, we can also change it to turn continuously when doing a stop bath or washing. We're really excited to develop our next roll of film with this cheap DIY semi-auto developing system. While we were having fun with our project, we were actually drying some carbon fiber filament, as when printing the TPU lid, we saw the humidity was getting too high and starting to affect some moisture-sensitive filaments. So before we print nylon carbon fiber, we will dry it for 6 hours. I saw there was a filament dryer on the K1C page and it looked pretty nice. Okay, I will print some hanging clips with nylon carbon fiber. After the nylon is dried, it's pretty easy to print. The clips stick perfectly to the bed and the layers are clean. Since I don't want to steal my mom's clothespins and remove the metal springs to use for my clips, I will just use rubber bands or some TPU printed bands. They may not look as good as the original design, but they are still functional and I won't get in trouble. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The print quality has improved significantly. Compared to the same print produced by the original K1, the surface quality from the K1C is noticeably better. It appears that the input shaper calibration works better for the K1C than in the original K1. 2. The K1 was one of the fastest printers. For the new K1C, the top speed has stayed the same at 600 milliliters per second, but the actual usable print speed is around 300 milliliters per second. However, with the input shaper working better, I can push it a little faster, as seen with the Robo Alpaka model. I printed the infill at 400 milliliters per second, resulting in slightly faster print times. 3. It comes with a tri-metal heat break and a hardened steel nozzle. With this setup, I can print all materials including PLA, PETG, TPU, ASA, nylon carbon fiber using a single hot end, without the need to switch between a regular hot end and a high temperature hot end. This feature is pretty handy when working on projects that require the use of different filaments. 4. The screen interface has also been improved, allowing for more control in expert mode. Unlike most printers with Auto-Z offset that don't allow manual adjustments, you can still adjust it according to your requirements. For example, with my number slider model, I typically prefer the first layer to be slightly higher rather than too low, as the tiles need to have gaps between them in order to slide smoothly. 5. The upgraded all-metal extruder indeed works better. It grips filament more effectively, resulting in smoother extrusion. Even when switching between TPU, nylon carbon fiber, and PLA, it maintains a strong push force to extrude filaments without issues. 6. You can choose to print within your local Wi-Fi network or completely offline using the USB drive. This could be important for someone who creates their own designs and wants to keep their files secure. Now for the cons. 1. The firmware is not open source yet, so you need to use Creality Print if you want to print over the network. I did use Creality Print for most of my test prints, except for the Robo Alpaka model. The slicer is usable and is similar to Cura, but if you want more control over how you slice the model, Orca Slicer or Prusa Slicer are much better options. Since other new generation clipper machines from Creality, like the original K1 and the Ender 3 V3KE, did release open source firmware, I believe Creality will do the same for the K1C. If that's the case, you can install Fluid and Moonraker to use any slicer without having to sacrifice the network printing feature. 2. The quick swap hot end has been improved from the original K1, but honestly, it's still not really a quick swap. It needs you to remove 2 screws to open the cover, another 2 screws to release the heat break from the hot end, and there are also 2 spacers placed between the heat break and the heatsink. You need to unplug 2 cables for the heating element and thermistor, and after the new hot end is installed, you need to reverse the whole process. It's still better than the cheaty quick swap hot end, which requires you to remove and tighten back 8 screws. However, given that there already have been a few great examples of how a quick swap hot end should look, Creality could do more in this area. 3. The Auto Z offset is set too low. For normal prints, it should be fine and it still produces a pretty good first layer. However, as I mentioned before, if you need clearance on the first layer, you'll have to go to expert mode and manually adjust the Z offset. In fact, the first layer is consistently a bit too low every single time. I believe this is caused by the preset offset value set by the firmware after probing. If this machine used a textured PEI sheet, I wouldn't even notice it, as it would be more forgiving on the first layer. However, since this print surface is a flat, smooth sheet, even a slightly low nozzle can be pretty obvious. 4. Having an extra carbon filter is good, but it only contains very few small carbon pieces inside. I'm not sure if it's really useful or not. I think adding at least a carbon foam layer or HEPA layer would be much better, and it would cost almost nothing but should work much better. In conclusion, the K1C is a better machine than the K1. The improvement in print quality is obvious, and it can print a broad range of filaments right out of the box. While its speed may not be the fastest, it strikes a well-balanced combination of speed and print quality. Additionally, it requires no assembly, making it beginner-friendly. If you already own the K1, you can expect the K1C to address most of the issues you've encountered, particularly with the extruder. For those deciding between the K1 and the K1C, I'd say go for the K1C. For just $60 more, you can access all the new features and improvements. So, the K1C will replace the K1 on my recommendation list on AuroraTechChannel.com as the best budget fully enclosed fast printer. My website also tracks the prices of over 150 popular machines, including 3D printers, laser engravers, and CNC machines. If you're interested, I included the link below, along with a link to the Creality K1C. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.